Okay, in this video we're just going to go a wee bit further into our integrating trig functions. We've got a few results which come from reversing our differentiation results. So we saw earlier on that if we differentiated sec, we would get sec x tan x. Therefore, if you integrate sec x tan x, you will just get sec. We also saw that if you differentiated cosec, you got minus cosec cot. Therefore, if you integrate cosec cot, you get minus cosec x. And we saw if you differentiated cot, you'll get minus cosec squared. That means if you integrate cosec squared, you'll get minus cot. So these are all provided in the formula booklet, differentiation section of the formula booklet. So we're just going to look at 1, 2, 3 examples of this. Okay, this example says find the integral of cos 2x over sine of 2x, and the sine 2x is squared. So I'm just going to rewrite this first of all as cos 2x, and the bottom line is going to be sine 2x upon sine 2x. So I'll just really put that really as, I'm going to write that cos 2x over sine 2x. That's just going to be cot 2x, and then 1 over sine 2x is the same as cosec 2x. So we have got cot 2x and we've got cosec 2x, and we said earlier on if you integrated cosec x cot x, you get minus cosec x plus c. So here, if we integrate this thing, what you're going to get is minus a half times cosec 2x plus c. Now, the best way to prove these things to yourself is just to differentiate them again and see what you get. So if you differentiate the cosec 2x, you're going to get cot 2x, cosec 2x, and minus of that, sorry. And then if you multiply it, and also you're going to have differentiate the angle, you get 2. And then multiply it all by the minus a half, and you'll get what you need. You'll get cot 2x cosec 2x dx. Okay, this used to be quite a common one on the old exam spec, so we're doing this one just in case it comes up again. It says to prove that tan x is the integral of tan x, is equal to ln of sec x plus c. Again, first thing I'm going to do, I'll write down my integral again. It was tan x dx, and I'm going to rewrite it as a quotient. So I'm going to write it as sine x over cos x, sine x over cos x. And now if you notice, it's almost in the form f of x on the bottom line and f dash of x on the top line. So I'm just going to change it a wee bit so that it is definitely in that form. So if you differentiated cos, what you would actually get is minus sine of x. So that's clearly not the same, so put a minus outside the front. So it's now in the form f dash of x over f of x. So if you integrate, you'll still have the minus outside, and it'll be ln of modulus of cos x plus c. Okay, just exam technique here. If you get to this point and you think that's not what I want in the answer, that's not, I've done this wrong, don't be scoring anything out, because you're only actually a couple of steps off being there. So never score anything out. Even if it's a proof and you haven't got there, you've still got some marks for doing this. Okay, if we just move on from this, what you can then do is bring the minus up. That minus in front really is minus 1. So it can come up and you've got cos x, modulus of cos x, that's now all to the power of minus 1. So the power of minus 1 means the reciprocal of it, and the reciprocal of cos is sec. So that is modulus of sec x plus c as required. So you know you've got this right. Okay, this one is similar to our example we did on integrating tan squared. Now, I don't know that, so like our integrating tan squared, I don't know how to integrate cot squared. So, but what we do know, I'm just going to write down my identities. So this is where I'm going to get this from. Sine squared x plus cos squared x equals 1. And how you get cot, you would divide your cos by sine. So we're going to divide this all through by sine squared. So divided through by sine squared, you get 1 plus cot squared x. And sine 1 divided by sine squared is cosec squared of x. So therefore, cot squared of x is equal to cosec squared of x minus 1. And we know how to integrate the cosec squared from our results we've just been given, and we also know how to integrate minus 1. So we're good to go. So back here, we'll rewrite this thing as the integral of cosec squared of x minus 1 integrated with respect to x. And our results we got earlier on said if you integrated cosec squared, what you got was minus cot x, integrate minus 1, you'll get minus x, and then plus your constant of integration. Okay, that is us done for this bit. You're now ready to do topic 7 and exercise 6.